Could you explain to the audience a bit what those multi-level models are and why they're useful?
Oh, sure. Um, so multi-level models are useful because for several reasons. Um, one way of framing it is that almost any method, a standard method you use, whether it's machine learning based or statistics based, will assume that your observations are identically and independently distributed. Uh, in reality, doesn't often hold. So it could be, and that's after conditioning on everything you're conditioning on your model. But if you've got kids who grew up in the same family together or go to the same school together or patients in a hospital or incarcerated individuals in a prison, there are going to be things that are similar to them because they're in that same environment, right?
Mhm.
That we're not capturing just in
Right.
the covariates or features that we've measured on them. So our error structure is just going to be wrong. So if we then try to get, confidence intervals on things, we'll be overconfident in things because we think that everything's independent when actually all these are pieces of information that are highly correlated. It's instead of like 30 unique contributions, 30 individual data points, it's maybe more like 15, right? But you're
Right.
not accounting for that in your uncertainty estimates. So Andrew always says we can't sell the book by saying they're going to have bigger standard errors, but that is kind of the thing, right? That you're going to be more honest about your inference. Another reason that multi-level models can be super helpful is that they help us to understand phenomena that happen at group levels versus individual
Right.
levels,
Exactly.
right? So you can explicitly partial out the different parts of the relationship that are happening at each of the levels of aggregation, which can be extremely helpful in understanding,
Yeah. So
all the complex phenomenon.
remembering back to some of the data and models in your 2006 book back in my PhD days, I think a lot of the examples related to things like school districts or individual classrooms. So what you're describing allows you to then, so instead of just assuming that all the school districts or all the classrooms are the same, you break them into groups. And so you could have a model where you have one tier of subgroups where it's school districts, and then another tier of subgroups within that. So this like three-level hierarchy, where that deepest hierarchy, that deepest level in the hierarchy is the classrooms. And just as to kind of be repeating back to you what you just said, this then allows you to make inferences at the classroom or at least the school district level that otherwise you wouldn't be able to do. You could only with a more traditional regression model, you might only be able to make inferences at the whole state level or country level, as opposed to those more granular inferences.
Yeah, I mean, there are kludgy ways of doing it, right? So you could throw in fixed effects for those things, right? There are other ways of reflecting that. And then you could throw in interactions between school district and something else. It's those are strategies that come with their own assumptions and aren't necessarily going to capture exactly what you want. You might have to do a lot of manipulation to pull out the parameters that you actually care about.